Hey class, this is Gigi from Kauai Community College. In this video, we are going to compute the limit by cleaning up the complex fraction. Okay, so here, looking at that, I am just conditioned to go ahead and clear a complex fraction. And to clear a complex fraction, we are multiplying by 1. And the 1 is whatever the least common denominator is divided by the least common denominator of all of the denominators. So this denominator over h is 1. So between 1, 5, and 5x, 5 plus h, the common denominator is 5 times 5 plus h, 5 times 5 plus h. So then we will have the limit as h goes to 0 of, and you have seen so many of these when you're doing the definition of limit. Definition of derivative, right? We will have then on the denominator h multiplied by 5, which would be 5h times 5 plus h. And then on the numerator, the first term right here, this is going to get divided out. So I will just have 1 multiplied by 5, which would be 5 minus 1 multiplied by the 5 is going to divide out, multiplied by 5 plus h. That is what is there, right? So we will have here 1 times the 5, and the other one was that. And so when we clean this up, limit as h go to 0 of, on the denominator, 5h times 5 plus h on the numerator. When we distribute the negative, this would be negative 5. And so negative 5 and positive 5, that's 0 out. And so all we have left is just negative h, right? So then negative h divided by h is negative 1. So really we have on the numerator the limit as h goes to 0 of negative 1 over 5 times 5 plus h. Now what happened when h is approaching 0? When h is approaching 0, I have negative 1 over 25, and that is the final answer. Okay, now question you might be thinking of is, couldn't we use the L'Hopital's rule? Because that's a very useful thing that we have learned in this unit. Okay, so let's see. So really, really depend on when you have learned the L'Hopital's rule. Before you have learned that, you probably only thought about cleaning the complex fractions, right? But now that we know the L'Hopital's rule, we would say plug in 0. And when we plug in 0, we do have the numerator is 0 and the denominator is 0. So when we have 0 over 0, L'Hopital's rule will apply. Okay, so 0 over 0, so L'Hopital's rule will apply. So then we would say limit as h go to 0 of the derivative of the denominator, which is just the derivative of h, is 1. The derivative of 1/5 is 0, and the derivative of that, well, I'm going to go ahead and write it over there. That is 5 plus h to the negative 1. So when I take the derivative, I would move the exponent down, so that would be negative 1 multiplied by 5 plus h, and then 1 less than negative 1 would be negative 2, which equals to negative 1 over 5 plus h squared. And we don't have to worry about the inside derivative because it is 1, right? So this right here, I will have negative 1 over 5 plus h squared. Now take the limit as h go to 0. Well, so when h is going to 0, the denominator is 1, so I don't have to write that. So that would just be negative 1 over 5 squared, which is 25. So same answer, okay, just how we arrived at the answer. Is just where our brain takes us. And also, sometimes you don't, in a calculus class, you don't learn the L'Hopital's rule until way later. So that you really do have to learn the method of clearing the complex fraction. Or you would clear the complex fraction if it wasn't 0 over 0 or infinity over infinity type, right? Then you would have to resort to finding the common denominator to clear that.